In this video, we'll be looking at the valid palindrome problem. We'll implement a method which accepts a string as input and returns true if the string is a palindrome and false if it isn't. For example, kayak is a palindrome because it reads the same forwards and backwards. But what about this? Well, when considering if a string is a palindrome or not, we ignore spaces, punctuations, and the casing of the character. So this transforms into kayak, which is a palindrome. Let's look at a different example. Is this a palindrome or not? Well, when trying to match the character pairs from both ends, we see that this E and the A do not match, so this is not a palindrome. I think you get the point, so let's go ahead and implement this. Since we'll be comparing pairs of characters, let's break our string into a character array. So now we have a character array. Let's filter out spaces and punctuations and also convert all characters to lowercase. I'll start off by creating a new list. Then while iterating through the array, I'll check if the current character at each index is a letter or digit. If it is, I'll convert it to lowercase and add it to the new list. Let's see this in action. We skip the period, the space, and the exclamation point. We also convert the uppercase A to lowercase. Now we've filtered out special characters, let's move on to the final step of our algorithm. I'll declare two indices, a left index which starts at the beginning of the list and a right index which starts at the end of the list. We know a string is a palindrome if the first character matches the last character, the second character matches the second to the last character, and so on until we get to the middle of the string. So while these two pointers have not crossed each other, we compare the characters at those indices. If the characters match, we increment the left index to move it forward and decrement the right index to move it backward. However, if any pairs of characters do not match, the string is not a palindrome and we return false. If the indices cross each other, the string is a palindrome and we return true. Our time complexity for this algorithm is order n, since we have three mutually exclusive loops which each run in linear time. Our space complexity is also order n, since we essentially need two additional n-sized arrays or lists. The first one when we break the string into a character array, and the second one when we filter out special characters. So the obvious question is, can we do better? Well, because we have to visit all characters in the worst case, we can't do better than an order n time complexity. But there is still room for improvement when it comes to space complexity. Using just two indices, we can directly figure out if a string is a palindrome or not, bringing the space complexity down to constant time. So let's see how to do this by re-implementing our method. Again, we'll always assume the string is not null. If the string is empty, we'll return true, since an empty string is the same from either direction. Note that our previous implementation also handled this test case, but implicitly. Alright, back to our standard example. Let's declare our two indices again. Left will start at the beginning of the string, and right will start at the end of the string. While the two indices haven't crossed each other, let's keep track of the current left character and the current right character. If these two match, we'll increment the left index to move it forward and decrement the right index to move it backward. Notice that the current left character is now the period. We would like to ignore this. So if the current left character is not a letter or digit, let's increment the left index to move it forward. Calling continue skips all the code underneath and moves us to the next loop iteration. Okay, now we're comparing a lowercase a to an uppercase a. So let's make both characters lowercase for uniformity. Now since the characters are both equal, the left and right indices get updated. Now the current right character is the exclamation point. So let's add a check for this scenario as well. If the current right character is not a letter or digit, we'll decrement the right index to move it backward. The space character is also not alphanumeric, so we decrement the right pointer. And now, both indices are equal. The y is obviously equal to itself, so we increment the left index and decrement the right index. At this point, the indices have crossed each other, so we exit the while loop and return true because the string is a palindrome. Now, if at any loop iteration, a pair of characters do not match, the string is not a palindrome and we return false. Let's look at the algorithm complexity of this new implementation. The time complexity is still order n. However, the space complexity is now constant since the additional space does not increase with the size of the string. And we are done. If you enjoyed this video, don't forget to like it. Also consider subscribing if you haven't done so already, and I'll see you in the next one.